All right, I went with the second group of integrals for our week 6 project. The first one is pretty straightforward. We have the integral of 1 over 1 plus x squared dx. You just have to recognize that it's just a squared plus x squared. In this case, our a value being 1. So if you're familiar with a common integral, hopefully by now, you can see that it's just basically the inverse tan form. So just more of a recognition and a perception than any kind of algebraic manipulations or anything like that for the first one, just pretty much learning how to read it. The second one, just a very minor manipulation, just taking the x of the numerator, bringing it off to the side, just kind of showing us on our u substitution what we want our x dx to equal. So in this case, 1/2 du. Setting it up in our u substitution form, making sure to bring that 1/2 constant out in front. Continuing on with our u substitution algebra, and then just plugging in our u value at the very end. The third one, 2x plus 3 over 1 plus x squared dx, just taking that fraction and splitting it up into two parts. Beginning with the first one, just bringing that constant right out in front, cleaning it up a bit. Once again, taking the x of the numerator, bringing it off to the side, kind of showing us where our u substitution should take us to get that lineup, that match of the x dx. Once again, bringing that 1/2 out in front, getting rid of the constant, where it's just a simple, basic natural log form, and then just switching out my u value at the end. So that's the first half of the two parts of the fraction that was split up initially. So then we have our second half, just bringing that 3, that constant, right out in front. And then right off the bat, you just see that common inverse tan form again, that a squared plus x squared. And so then just taking the two, adding them together, getting the final answer. And for the fourth one, we have e to the x over 1 plus e to the x squared dx. Similar to the other problems, just bringing that numerator off to the side just kind of helps you see it a little better, at least for myself. A little u substitution of just setting a u equal to e to the x. And then, once again, that inverse tan form that we've kind of been hitting on this group. Just taking it from there. Once you can get it into a common integral form that we're familiar with, you can really just plug and chug.